So in this video, we're going to evaluate the definite integral. First one is the definite integral from 1 to 4 of 3 square root x dx. So the first thing I want to do is I want to convert the square root to be x to the 1/2. That way we can use our power rule. Remember, whenever I'm integrating, I add 1 to the exponent. So I add 1 to 1/2, I get 3/2. And then I divide by that number, 3/2. And I want to evaluate from 1 to 4. Okay, so that's what that bar tells me. Now, I didn't put a parentheses around it because, I don't have any plus or minuses going on. So if you don't have your expression split up over plus and minuses, you could probably get away with not putting the parentheses around. I mean, if you want to be nitpicky, then this would be, how the correct way to write it like that, okay? Anyway, whenever I simplify this, keep change flip tells me that the 3x to the 3/2, and then this flips to be 2 over 3. Those 3's cancel, so I just have a 2, right? And then x to the 3/2 is taking the square root of x cubed. Okay? If I evaluate this from 4, f of 4 minus f of 1, this will simplify. And so what does it simplify to? Well, 4 cubed here, that's 64. Square root of 64 is 8. So I have 2 times 8, which is 16. And then 1 cubed is 1. Square root of 1 is 1. So 1 times 2 is 2. So minus 2. And then that gets me 14. So f of b minus f of a, or f of 4 minus f of 1, gets me 14 here. Next up, I've got another definite integral of sines and cosines. Anytime I see sines and cosines divided like this, I start thinking, how can I split this up to where it makes it easier? So I'm going to divide this up into 2 fractions. So I'm going to strip off one of my cosines and put it over here. So I have 1 over cosine. And then that leaves me a sine up top and then one other cosine in the denominator. Okay, so that is going to simplify. I can use my trig identities. 1 over cosine is equal to secant. And then sine over cosine is equal to tangent. And now you should be thinking, oh, I know what the integral of secant tangent is. Integral of secant tangent is just secant. It's one of those rules that you need to memorize, right? This is why it's important to memorize the rules so you can just write out the answer. And so I evaluate it from f of b minus f of a. And so I plug in secant of pi minus secant of 0. Now, if you're a genius, great. You got the answer. Just type it in. You know it off the top of your head. But my brain doesn't think in terms of secant. Mine always thinks in terms of cosine. So I do the reciprocal function. 1 over cosine is secant. So secant pi is 1 over cosine pi. And then secant 0 is 1 over cosine 0. So pi, whenever I think about the unit circle, cosine goes, pi is all the way around to right here. So cosine, the x value is -1 here. So that's going to get me a -1 in the denominator. Cosine is 0, so the angle of 0 is right here. So this is 1 comma 0. So this cosine of 0 is actually 1, okay? So it looks like I have -1 minus 1. Whew, what is that, just -2? Oh, that's a tough one, right? So simplify, you get -2 there. Okay, so that's where the pre-cal comes into play. Oh, those glory days of the unit circle, right? Okay, so another algebra trick you're going to run into is you have a rational expression, you need to divide. So you divide and conquer. Anytime I see that plus or minus in the numerator and just some expression in the denominator by itself, I want to divide it out. So I'm going to divide these two things first, and I have u over u squared. And then I divide the second two things, I get 1 over u squared. So these will simplify algebraically. the u's cancel. I have one u up top, one u, two u's down low. That leaves me one u here and no u's up there. So there's just 1 over u for the first one. And then this one right here, I can actually simplify this. I can flip this up to the numerator. And remember, if you have like an exponent that's positive in the denominator, but you flip it upstairs, you become a negative exponent just like that. So I'm going to use that rule right there, negative, negative going on there. Now I can apply the power rule to the second piece, and guess what? This one is a special one because the power rule doesn't work. The integral of 1 over x is ln absolute value of x, right? So the integral of 1 over u is ln absolute value u, okay? Now I do use the power rule here. I add 1 to the exponent, gets me -1, and then I divide by that -1, okay? The reason the power rule doesn't work here, you think about this, this would actually equal u to the -1, right? If I add 1 to -1, I get u to the 0, and then I divide by 0. I cannot divide by 0. Oh, no. Oh, right? So you can't divide by 0. Since you can't divide by 0, that rule kind of falls apart. So then you got to know, hey, look, I got to use something else. That's that ln absolute value of x, or u for this particular problem. Okay. Integrate from from 5 to 2, f of b minus f of a, right? So I plug in 5 first for everywhere I see a u, and then I plug in 2 everywhere I see a u. Now I've actually see a problem here. I should have had this to the -1 and this to the -1, right? Because that's to the -1 right there. So this is technically, I done messed up. Okay, I done messed up here. Because 5 to the -1 is equal to 1 over 5. And 2 to the -1 is equal to 1 over 2, right? So need to make sure that you have that written correctly, unlike what I have written here. Those aren't right, okay? So this is ln 5 minus ln 2, which that's okay. But then I need to collect like terms with the 5 and the 2, and that's where I get 5, and then minus 2 gets me the 3 here. But we know that that's not the correct answer. The correct answer is 1/5 minus 1/2, right? And so, you know, oh gosh, common denominator. So that means I'm going to have to do 2 over 10 minus 5 over 10. So that should say -3 over 10 there, okay? So I have this right here, which it will actually simplify. Log properties, when I subtract logs, I divide the arguments. So that was -3 over 10. I'll have to remember that. And so this problem should be, the final answer is -3 over 10 here, okay? Sorry that I made that goof there. So screenshot that, all right? Okay. If you don't want to combine these here to make that, that's okay. This is just, you know, I just wanted you to see that in case, like a back of a book or something you check your work with against, in case you get some different answer. You don't freak out and think you did something wrong, okay? All right.